So just questions to start off. Sort of, how did you go with the assignments? Yeah. Any questions?
Maybe in the part of the to identify the independent variables, independent variables, because the hypotheses say some kind of affirmation, but for example, there are many independent variables that you can consider, although they are not declared in the hypothesis sentence, right? For example, age, gender, and this kind of stuff. I have.
Well, ideally, you should have for each independent variable a separate hypothesis. So, well, in each hypothesis, you should have at least one dependent and one independent variable. So just to clarify, dependent variables and independent variables. So dependent variables are mainly, well, to some extent, the measurements you apply. So your questionnaires or your task completion times. And your independent variable are the conditions you are interested in measuring. So a hypothesis could be, for example, there is a difference in task completion time between, and we always had the example of the we, the connect, and the move, for example, or user experiences. So the dependent variable in this sense would be either the user experience or task completion time. So this is your measurement, and your independent variable would be the interface, in this case, the we, the connect, and the move. And so ideally you have for each hypothesis, because you want to test it with a specific test, with some statistics. Yeah. So ideally you have a clear sort of one dependent variable and one independent variable.
I remember one, the last example was about children making some kind of task, but the hypothesis only say children. But I was thinking that the age of the children is important, and it's not declared in the.
Well, depends on your specific research question, I guess. If you're interested in, can you just flip to? I don't know the exact hypothesis. Can you just, or sure. Can you?
No, I have it in the.
So. In the end, it really depends on your research question. If your research question is to compare children of different age groups, you should specify this in the hypothesis. If you're interested in the difference between children and adolescents, you specify this in your hypothesis and then design your study accordingly to test for this specific difference. You also can have multiple independent variables to some extent in a hypothesis. So, for example, if you're interested in a interaction effect between independent variables, then you can specify this in your hypothesis as well. And then you would have more than one independent variable in there. Just be sure to be sort of, just be sure to formulate the hypothesis in a way that you can test it afterwards, and that you already have a good idea how you want to test it, because otherwise you're going to run into problems. If you if you just formulate hypotheses that are not testable, or you don't have a clear idea how to test them, well, you have apparently. Yeah.
But what's my question? Because how much specific must be the?
Well, ideally you are as specific as possible, and that just makes a lot of things easier, and for you and for, well, in the end, the reader as well, when they read your report in the end. So last time we talked about different study designs and evaluation approaches. Any questions on so far what we talked about there? And part of the assignment were to around study designs anyway, I guess, just to refresh we were talking about here. We stopped around here somewhere, I think. I think that was the last slide last time, wasn't it? Yeah. Just to quickly recap, I guess, as a summary of some things we were talking about. So either when you're writing a research paper or a report, or are reviewing a report or reading a report, that's sort of some of the things I would sort of recommend to focus on, I guess, in terms of looking for specific things in user studies. So one of the most important aspects is to look out for, is there a clear research question and are there hypotheses stated in the report? So that's sort of, as we said, the crucial bit. So that's basically what it's all about. And that's where there always should be a clear research question and a hypothesis, because that in the end really defines your whole paper, your whole report, your whole reasoning for doing your user study. Then is everything well described properly? Are the participants how were the participants recruited? Who are the participants? So which study population are you dealing with? What materials were used? What were the methods, the chosen methods? Are the methods appropriate for answering the research questions and the hypotheses? In the results section, well, were the right methods used and applied in a correct way? There's several small things I guess you would look out for. We talked about the alpha level for hypothesis testing. Was this set before they started to do the test, or are they just quite liberal in just floating and adjusting the alpha level afterwards, which shouldn't happen normally? Are the statistics and everything reported properly? Sometimes authors just report, there was significant difference, but don't provide you any specific information about the mean, standard deviation, and the actual statistics that resulted out of the test. And those things should be in there. That just makes it clearer for you and for everybody to make to get a clear picture if the proper methods were used and if the interpretation of the results is actually correct or not. And in the discussion, again, are the results interpreted correctly? Are they embedded? Well, the discussion should basically be that you embed your findings into a broader picture. You can discuss, for example, we found that our new approach works a lot better, and this goes in line with prior research that found that augmented reality is a more intuitive whatever interface than a virtual reality-based interface for, again, whatever your question was. And something we talked about, sort of just keep an eye out on, well, whether the results and the reporting results, if that changed in the discussion from the results section, because that sort of sometimes happens, and just keep an eye out for that. So to give you some examples, I guess, to get an idea how those study designs are used, just want to talk about examples from what I sort of was about sort of examples in emerging technologies. That's what we deal with quite a lot here in the lab. There are some specific challenges to when you're dealing with novel technologies rather than standard computer interfaces like desktop interfaces, such as, well, there's still a lot of technical challenges to be resolved. With standard computer interfaces, there's still some challenges in terms of technology, but with augmented reality interfaces, for example, there's still limited reliability in terms of tracking and all those kinds of things. So there's certain challenges for HCI research still to be resolved. One other difficulty is that there's hardly any end-user products. So sometimes it's not really clear if you're developing a new system who the end user is going to be in the end. If you have sort of a clear idea about, well, this is going to be a product, it's probably a little bit easy then to define a specific end user. And sometimes it's quite difficult to define this end user. And then the question arises, well, if I don't know who the end user will be, whom am I going to recruit for a test And if you just recruit somebody, the question arises, well, how valid is the test I'm doing? And we're going to talk about participants and recruiting participants today then as well, and sort of how to deal with those issues. Well, a lot of times, especially if the research is very engineering driven, you're faced with a solution that looks for a problem. That's what happens quite often in research. Somebody comes up with a new technology or a new solution for stuff, and then you start to think like, okay, so what are we trying to solve with this new technology? Well, one example was a new display interface. We had sort of a partner company who developed a new display interface, and they got quite a lot of investment money to develop the interface, but in the end, they actually didn't have a real market for it. Then they approached us to basically somehow help them to come up with ideas on what actually to do with this new type of display. And that was sort of, I know, nobody was really happy with this type of sort of situation, I guess, and even so the research ideas we came up with weren't really very strong, I guess, And every time, you can knit a user study around something, and then you can try to publish it. But even the reviewers then, came back with, reviews like, well, so what did you actually do there? What is it for? So sometimes you deal with this type of problem, I guess. So I guess one of the messages is it's probably pays off quite a lot to do your homework before. But, in the end, I think you have to strike a balance. There's certain, things to say in favor of just pushing technology and technology-driven research. But at some stage, it should be balanced between technology-driven and user-driven research. And somewhere they have to meet the two approaches, I guess.
And what's the consequence of bad evaluation in prototypes? For example, I was thinking in this example in the paper that they test a training system for geometrical training, I don't know, and they compare with traditional classes, and there are not a better performance with this system. What happened with it? I suppose this kind of research is for products research, or some companies make this kind of research.
This study was actually, I was involved in the study, in this specific study. This was done mainly, the application itself, and we talk about the example then afterwards. The application itself is aimed at educational, it's an educational application. So the idea is to provide an interface for students to work on geometry problems in 3D space. And the idea with the study was to evaluate if there's a positive effect on spatial abilities when you're training with this application, I guess.
Or against traditional.
Yeah, and so and then the idea was to see, well, is there any advantage of doing it in 3D with this new type of interface compared to a traditional type of interface? Because geometry education applications are out there, computer-based ones, and so there's always one of the questions is, well, if you come up with a new idea, is there any advantage over a existing approach of dealing with the same problem? And that sort of, you find this quite a lot in, as a research question or research problem. You've come up with a new idea, and in the end you have to argue, well, why did you come up with a new idea? Because you thought there's a certain advantage over a traditional approach, and then that's how you can approach a research question. So studying the advantages of your new approach compared to a traditional approach, and then compare the two. In the end, you not always find a difference, and that's just part of the game, I guess. You make your best effort in if you assume that there will be a difference, that's why you came up with the idea in the first place. You create your study accordingly, but sometimes you just don't find it to be effective, or it's just the study design was not good enough for detecting a difference if there was one, or no, it can be a whole lot of different reasons. Or was this part of the question? Or
was about this because, for example, in the results claims that there are not significant difference between traditional systems and these new systems.
Mm-hmm.
So I was thinking, what happened after that they evaluate the system? They say, okay, not works better. We're gonna stop with this research, or we're gonna try to find another.
Well, not necessarily. It depends. One of the, well, it can go a lot of different ways, I guess. Ideally, what happens is that not finding a significant difference between two things doesn't really show anything yet.
Okay.
It just means that you haven't found enough evidence that there is a difference. It doesn't tell you, not finding a significant difference between two conditions doesn't tell you that they are the same. That's what we talked about.
Okay.
It doesn't tell you that they are the same. It just tells you you haven't found enough evidence that there is a difference. If you wanted to test for equivalence or for sameness, you have to use other tests rather than this normal statistics approaches we're going to talk about in the next 2 lectures. So what actually should happen, based on your results and your study, you come up with a good idea or assumptions, or a good assumption what either went wrong in your study design. Could be either, you didn't design your study appropriately, you didn't have enough participants, the prototype was not good enough or whatever. There's a whole bunch of reasons, and that's basically, you can probably learn some of those things out of your results, and just looking at your data and how you designed the study. And then what you probably should do, that's what you put in the future work, how you want to progress. So either make some changes to the study design or your product or your prototype, and then retest it, for example. Or you can say, well, we don't think it's a good idea anymore, and just just put it in the drawer. And I guess it really depends on how you personally then as a researcher deal with the results. One of the problems sort of is that a non-significant or a study with no clear results is a lot more difficult to disseminate. If you want to publish a study that doesn't have clear results, it's very difficult to get a paper accepted somewhere, in a journal or in a conference. Although it's, people say about no results, no result is a result as well. And, everybody agrees, well, most people agree with that. But as soon as you submit it to a paper and there's reviews, you always will get like, oh, well, there's limited contribution because those guys didn't find anything. So we might just, not accept it and just go for a paper that found some brilliant, whatever result. And that's what sort of, it's sort of part of what's called the, the file drawer effect. And that means that there's a huge, in research literature, there's actually a bias towards studies showing an effect, because those studies are a lot easier to publish. And so there's a lot more. So if you have sort of 5 studies, 2 showed an effect, 3 didn't show an effect, you can be sure that the 2 studies who showed an effect are more likely to be published in the 3 studies that haven't shown an effect. So, but then if you read the studies, you only will find the 2 studies that showed an effect. You won't know about the studies that haven't shown an effect. So you have a certain bias in research literature, actually overestimating certain effects for, and that's a known problem. And there's sort of, people try to deal with the situation, well, with this, coming up with estimations on actual effect sizes, but it's sort of a bigger sort of discussion and problem. But it's actually quite. It's not an easy question to answer, I guess. What happens with results that are not clear or not significant or not? They tend to get published in venues, journals, or conferences that are not top tier, I guess. Yeah, that's just what, it's just a reality, I guess, in the end. So coming back to what we talked about, so another challenge with novel technologies is that you get a lot of one-off prototypes. This is sort of part of the sort of this discussion as well. So you develop a new system, a new idea, test it, and it doesn't, it doesn't really show a huge advantage over an existing other idea or prototype. So you do one test and then learn something from it, but then you develop a new prototype, test it as well. And so it's then difficult to basically extract some unique sort of generalized lessons learned from, because you get a lot of, if you do multiple studies with web pages, for example, there's a good knowledge base on how web pages should be designed, because there's so many web pages out there. They have been studied, and you can sort of extract sort of a common theme on how to design your web page or your computer interface, your desktop computer interface. And that's a lot more difficult to extract those common themes with novel technologies, because again, you have a lot of one-off prototypes that have been tested, but then either put into the drawer, or you progress to other, develop new prototypes. So it's a lot more difficult to basically learn from somehow other people's research to some extent. And another potential problem is sort of linked to that as well. We have got so many different implementations. If you talk about, for example, augmented reality, what's augmented reality? Well, you have a core definition. It's tracked. Well, it's registered in real time. It's 3D, and it's a combination of virtual and real. But how this is implemented, you get so many different ways of implementing it. You get it on mobile phones, you get it on desktops, you get it on tablets, you get it on head-mounted displays, you get it on those. You can implement augmented reality on handheld, on this handheld display, for example. You can have audio augmented reality and visual. There's so many different implementations that it's really difficult to, again, come up with common themes for usability heuristics, for example. If you look at the Nielsen usability heuristics, what we're going to talk about when we talk about more specifically about usability, there is, they are aimed at desktop interfaces and specifically actually web pages, more or less. So a lot of those heuristics, I probably have some slides afterwards, are basically aimed at traditional computer interfaces. So the question is, can we use these for new types of technologies? Some of them, yes, but not all of them. And that's sort of, again, a little bit challenging. So, but that's the question, are traditional methods suitable or not? Well, to some extent, some are, but then you, again, have some of the challenges where you have to find new ways of studying your problem, because you're dealing with 3D space rather than just the 2D desktop. Sometimes what's becoming more and more interesting with not just with new technologies, is assessing user experiences. So traditionally, usability evaluation looked more or less into efficiency, task efficiency. How can we make a interface more efficient to use? How can we just scrape off some interaction time? How can we make it faster? How can we make it less error prone? Or and those types of questions. With some technologies, it's probably not the most interesting question to some extent, because if you, just an example with the Wii and the Kinect, is task completion time the most interesting question? Well, not necessarily. Could be, but it's a gaming application. For gaming application, other questions can be quite interesting. Like user experience, for example. again, the problem is, how do you assess user experiences? And that's one of sort of the questions I'm quite interested in, to find good ways of assessing and testing user experiences. And I haven't found the Holy Grail, unfortunately, so I can't tell you that. And well, others probably didn't as well, because otherwise we probably would know of the Holy Grail. So it's I guess quite an interesting research field, and I think it's becoming more important and more active, but there's no definite best answer out there yet, to my knowledge.
And for example, thinking in the companies which develop some products, they do this kind of evaluations before to launch the product to the market.
You can ask the experts here.
Or they do it after, because I'm curious about that, because emerging technologies are rushed all the time now. They have short periods of development, and maybe they don't take so much time to evaluate all the features of the product. So
the answer is, I guess, to some extent, and a lot of it's informal, rather than formal test programs. A lot of it's also based on historical products, also on the type of industry we're in, competitors' products as well. Because if we're selling, for example, our radio to replace a competitor's radio to a customer, they want to be able to pick our radio up and use it. So there are sort of similarities, I guess, but in terms of a formal test and evaluation program, that's why we're here. Because
what, from your perspective, what are the main reasons why it doesn't happen already? Is it more historical thing, or is it it's just a time pressure, or what's the main reason why it's not happening already?
I think Taking to Pass has always been a technology-driven company,
Uh-huh.
and the whole user-driven research is just coming in now, or has been coming in over the last few years. It hasn't been properly formalized, and that's what we're doing now.
So it's more historic question, I guess, or is yeah.
Yeah, we have had, for example, user interface designers in the company, people focusing on user interface design, but in terms of usability, it's bigger than just user interface for our products. There's a whole bunch of things that impact the usability of the product.
Mm-hmm.
The user interface design side of things is a small group.
Mm-hmm.
Started off with just one person. It used to be done by software engineers. It's now, I guess, being done by software engineers again. But I think many years ago, 10, 15 years ago, it was sort of done around what was convenient from an engineering point of view, rather than what was convenient from a user point of view.
Mm-hmm.
So we're working on changing that focus, and now we're getting a bit more traction, I guess.
And so if you, let's say, after the course, let's say you know everything about usability testing, ideally. What would be then the main challenges in terms of applying this to develop in a product cycle?
I think it's the important thing is to bring it in early, rather than at the end, because then it's too late, because a lot of investments have been done at that stage by the time you get your product done. So actually changing the design process and the engineering process to have early testing, and testing it early and testing it often before you actually prototype.
Are you quite confident that this then will happen on a regular basis, or will be an integral part of the development?
Well,
because sometimes you get people arguing, well, it just takes so much time, it's cost, it's this and that, So although we know that we should do it,
Well, I guess what we're trying to do is set it up in such a way that a bunch of it happens offline.
Mm-hmm.
As well. So there's research going on all the time that we then incorporate into our products. What we do in the mechanical department is we test early, and we sort of design for test.
Mm-hmm.
And I think we need to broaden that into usability. So we're designing for usability rather than design a product then say, oh yeah, we can tick the usability box, or we have to re-engineer it or something. So don't know if that answers your question, but
there's a strong commitment of management towards usability, bringing it in early. They told us the door is open. You just have to walk out and do it.
Okay. Yeah. Okay. No, that sounds good. Yeah.
Part of getting a much better customer focus.
Yeah. No, I think it's sort of as you sort of said as well. This developed more or less in recent years as well. That sort of companies themselves and sort of the management from a top-down perspective is sort of appreciates the necessity of usability engineering, usability and user interface design as well for developing products, because in the end it's I guess it's a question of the market as well. If you're the only guys developing a product and the user sort of depends on your or the customer depends on your product, well, you can output whatever you want. It's like be happy to be our customer. But in a more global market where you have competition, you have to have something that sets aside your product in the end. And one way of being sort of different, I guess, is having a usable product in the end.
And I guess I'm looking at something near the old Apple. They had a much better usability focus than, for example, their competitors.
I think it's sort of multifaceted. I guess the Apple example. It's not just the usability. It's sort of certain decisions. It's basically the whole package they're selling. That just to some extent makes sense for a lot of people, and that's why they end up buying it. I guess and it's a lot of I think different aspects that what made it successful as it is.
I wouldn't underestimate the political drive that needs to happen and a shift in focus within engineering to accept that usability testing is done often and early. We can set up the most beautiful usability testing environment. We don't use it at the right time.
Yeah.
We're wasting our time.
Yeah, definitely. Yeah. No, it certainly needs sort of a mental shift in a lot of because in the end you're dealing with a multidisciplinary research team as well, where sort of different ideas, different disciplines meet and sort of I think everybody has to change how they approach, I guess.
Well, a lot of those ideas are conflicting.
Yeah.
A lot of the ideals are conflicting. For example, hardware engineers want a circuit board this big. But you put it in a product this big.
So. You raised the argument about time. We don't have time to do this. We actually been through some training exercises with external consultants, and they showed us some examples where exactly the same arguments were made. And they said in the end they found out they couldn't afford not to do it. Because actually it saved them so much time and money doing it the right way. Yeah,
because and that's and these examples are out there. A lot of them. It's just sort of some misconceptions that are out there that people think like, we really can't afford it because it's too expensive, it costs too much time. But in the end, as you said, it's in the bigger picture, it saves. Not always, but there's a good reason to assume that in the bigger picture it can save you quite a lot of effort, money, and time.
But it's not always easy to identify the return of investment and calculate it at the beginning. It's easy to look at it retrospectively. Yes, we did it, and it saved us something. It's hard to argue at the point at the beginning.
That's certainly a good point. Yeah.
The beginning is always, if you're developing a product, that's the best time to change. Develop a product, you get to the end, you've got the product, you find out it's wrong, or it's not suitable, or whatever. Then the cost to change is huge. Time, money, and everything. So get it right at the beginning. It's the least time and the least cost to.
In saying that, there's no guarantee as well. You can do the best usability tests, but there's no guarantee that you will get it right all the time.
No, but you might get it better than you would if you didn't.
Yeah. Okay. So let's jump into some examples. Well, just to start off with, I guess to give you sort of a broader picture of let's say, how much usability studies are done within, in this example, augmented reality related research. So there are studies out there that look into this topic, but we were quite interested in updating the data, and then it's already, 4 years ago that we did this study. We did a literature research in looking into how many usability studies or user studies you actually find in augmented reality research. So we went through quite a lot of research papers through sort of different keyword searches. Started with 6,000 papers, but reduced it to 3,000 at some stage, and we ended up with 550 articles we had to sort of scan through, I guess, to look for what they, in the end, were sort of focusing on research-wise. And to make it short, what we found is that only 8% of those 550 articles included some sort of formal user evaluation. And if you extend it to informal user evaluation reported, you still have only 10%. So there's only 10% of all the papers published on those, in this example, augmented reality based research. Only 10% included any type of user testing. And that was, quite interesting, I guess, to see. Well, to be fair enough, augmented reality being a sort of, again, an emerging technology, there's a lot of technological problems that have to be resolved, like, again, tracking, registration, and those types of things. But then still, it's quite interesting that there's only few papers that test what they do with users. So we then try to categorize the evaluation type and evaluation approaches used in those studies. So one category would be experiments that study low-level tasks, like perception and cognition. Other type would be experiments that look into performance and interaction with augmented reality interfaces. So these are your typical task completion times, error rates, and those types of studies. Experiments that look into users collaborating with each other and how to support user collaboration. And experiments that look into usability and system design. And not too surprisingly, what we found is that the user performance studies are the most represented category. And another trend that you see is that over the years, the amount or the percentage of the amount of user studies reported increases. So I think it's a good trend that you can see, that sort of the amount and sort of what you can see the importance of including user tests in your as part of your research is getting more and more important in recent years. We also categorize the papers according to research approaches and methods. So which types of dependent variables or measurements were taken. And so we look into objective measurements like times, error rates, task completion times, those types of things. Subjective measurements, questionnaires, for example. Qualitative analysis, that would be interviews, observations, those types of studies. Usability evaluation techniques. These would be, for example, heuristic evaluations by experts, those types of things. And informal evaluations, which we just included them for completeness sake. This is basically just informally asking people, at a demonstration, for example, so what did you... And interestingly enough, those results are still published in research papers. Again, longer discussion that we don't have to start now again. And not surprisingly, again, objective measurements are the most represented ones. And most of the time as well, what you will find that you will have a combination of objective measurements and subjective measurements. So most studies will look into not just task completion time, error rate, for example, but combine this with questionnaires, for example. So just a quick word about sort of what observations measurements are, I guess. Well, in the end, every measurement is in somewhat sort of a recorded observation. That's basically what it is. So a measurement is an observation that you record somehow, and you can do this, well, ideally with a calibrated measurement tool to some extent. And there's the objective measurements and subjective measurements. So just some examples for objective measurements. We talked about those task completion times. These are typical measurements you find in HCI research. Percentage of tasks completed, numbers of repetitions. You find physiological data like heart rate, movements or those type of things, or positions. If you track people, you can track their positions, where they look at, for example. So all these are objective measurements, typically found in HCI research. Subjective measurements, you will find quite a lot of rating scales. So if you rate different interfaces, which did you like best? Rankings, user satisfaction, and a lot of...
Likert scale is one of these categories.
Well, a Likert scale is basically just a way of measuring those. So Likert scale, do we have it here or do we have it? No. Likert scale is basically just a way of measuring those, well, questionnaire data. Likert scale is basically just your 5 or 7 tick boxes with different in categories like totally agree, totally disagree. And this is called a Likert scale in the end.
Okay, but it's subjective, no matter that you use numbers to...
Subjective in a sense that it's dependent on the subject.
Okay.
That it's sort of a subjective judgment on something. Okay. Because I ask you sort of, how do you, well, which one did you like best? So you have to make a subjective judgment on which you like best, and do you agree on that the interface was easy to use? And then you have to make a subjective it's quite often misinterpreted, I guess, that people write, they did some qualitative analysis and use questionnaires. It's not a qualitative measurement, because in the end you end up with numbers. So it's still a quantitative measurement. So with a questionnaire with a Likert scale, you end up with a number, and then you analyze the number. So you analyze quantities to some extent, but they're subjective quantities.
Okay. Yeah.
So qualitative analysis is basically a different approach to gather your data. So you're not interested in numbers, but you're interested in what the term says, in the quality of user interaction, for example. So this data you can gather in different ways, like formal observations, like video observations, audio recordings of user behavior. And then again, you're not interested in deriving numbers, but more observations and how those feed into your research question. Interviews fall into this category as well. And we talk about interviews in, I think that's the last lecture, about how to design interviews and what different types of interviews are out there for you to use. So qualitative analysis, it's a well-designed approach. So it's not just observing somebody. It's like, okay, we observed this and that. That's what I would call an informal user study, user evaluation. A qualitative analysis follows certain protocols, and there is. I don't know if we'll have time in our lectures to talk about qualitative analysis in detail. I guess we have one lecture on qualitative analysis. I'm not sure. Otherwise, there's I can give you some more pointers towards introductory reading material on qualitative analysis. So just a quick, we're going to talk about user evaluation techniques in, I think in 3 weeks, in more detail, just to give you a quick overview of what we categorized in this study as usability evaluation techniques. These are what I'd call non-user techniques. So you don't apply those techniques to end users, but those techniques would be, for example, categorized under evaluation, usability evaluation techniques would be, for example, cognitive walkthrough, heuristic evaluation, or expert evaluations. And the idea with those evaluation approaches are that you don't do these with end users, but you have experts that are not your developers, but experts for a specific product, and know a lot about sort of those heuristics, for example. You get those lists like in Nielsen's usability heuristics to give you sort of guidelines on how to design certain types of interfaces. And so experts would use one of your interfaces, solve a specific set of tasks, and then compare those against those heuristics, for example. So this is the idea of those usability evaluation techniques. Okay, not user-based. Wow, I hate them. I don't know why I put this animation in there. I actually hate them. So just some examples, and these are the examples given, most of them are given in the paper. Just before we go into the break, I guess I just walk through some of those examples to give you an overview about how different study designs and evaluation approaches and methods have been used in actual research. So those guys were interested in comparing basically different visual output. So it was a perception study. So the question was basically to get a better understanding of how users perceive text in AR, augmented reality, outdoor augmented reality settings. So they came up with a study with different text colors, different text backgrounds, and then compared those in a user study. So they started off with several different hypotheses. For example, a brick background will result in slower and less accurate task performance because of the visual complexity. They, in this case, recruited 24 participants. So the task, again, in terms of categorization, was low-level visual identification tasks, or perception-based task. The measurements are response time and error, your classics in terms of dependent variables. And they analyze the data with a repeated measures analysis of variance. And we're going to talk about statistics in the next 2 lectures, then how to analyze the data. Just some of the results, well, they found that the least errors were done with building background, and most errors with the brick background, which you probably can appreciate from this as well. So sometimes results are quite obvious, but unless you test it, you can't be sure, I guess. So this is just a classical example, I guess, of a standard approach of evaluating a question, I guess, a research question. Again, this is an example for a low-level perception-based study, but here they used subjective measurements. And so just probably to clarify what we talked about earlier. So subjective measurements in terms of judging stiffness of a virtual spring. So they had a setup with a phantom forced feedback. Was it a phantom? Yeah, I think sort of a forced feedback device, and sort of some different visualizations of a virtual spring. And so the task for the user was to judge basically the stiffness of the spring. So the metrics were what they call the point of subjective equality, or just noticeable difference of stiffness. So you know that's sort of a classic psychology-based measurement where you have two. Well, just imagine you go into the shop and you want to buy melons, and you get two different ones, and they are charged not by the kilo but by the piece. So what you basically want to have, you want to get the biggest one, don't you? Well, the juiciest one, but probably the biggest one as well. And so sometimes it's quite different to really judge. Basically, which ones? It could be a little bit heavier, but then there's just this amount of just noticeable difference of one being a little bit heavier and one being a little bit lighter. So it's one of those classic types of measurements, and especially in psychology. And so in this case, it was just a noticeable difference in terms of spring stiffness. So for more specific results, I guess just have a look at the summary paper. I guess it's not the reason for going through these examples. I'm not talking about the results, but more about the study setups and the measurements, I guess, to give you a broad overview of what has been done and what can be studied. So this is the example we talked about earlier. So I was involved in that study as well. So this was an augmented reality-based geometry education application. So students could solve their geometry-related problems in 3D space. So you can create spheres, cones, put tangents on it, do Boolean operations with different geometry objects, and in the end, it's a geometry education application. To create, work on your geometry problems in 3D space in a collaborative setting. And as one of the arguments is always for geometry and math teachers that this activity has a positive effect on spatial ability. So through geometry education, you actually get better at spatial reasoning. That's always one of the arguments. And so our idea was, well, we actually have to study this. And doing this in 3D space is a new approach of training 3D geometry, doing 3D geometry education. So the idea was to study whether a training within this environment has a positive effect on spatial ability compared to a more traditional approach as well. So the measurement we applied was those standard paper and pencil spatial ability tests. These are classic tests that you probably came across already. So these either you have those folding tasks. So you have a object on the left, and you have to tick the box on which is the folded object that results from. If you fold the fellow on the left-hand side, which of the right-hand side objects can result from that one? And yeah, great. And the other one, these are the Shepard-Metzler type of block mental rotation tasks, where you have, the idea is you have, again, an object on the left-hand side, and then there's always two objects on the right-hand side that match the left one, and it's a speeded, so you have to do this under a certain time pressure, and then always tick the two the two objects on the right-hand side that match the one on the left-hand side. And the idea is that you apply mental rotation to solve the problem. It's the idea. It's not, anyhow. Again, we could talk about this for longer, I guess. So we had basically, because there's different types of spatial reasoning, spatial ability, we had we had 4 different types of spatial ability tests to see if there's training effect on certain types of spatial reasoning. So there were 6 training sessions, so the students came in 6 times. We had a pre-test and a post-test, so they had spatial ability test before training and after training, and we looked if there's a difference in before and after. And we had different groups. So we had one group doing it with the augmented reality application. We had one group doing it with a standard desktop-based CAD type of application. And we had 2 control groups as well, who just didn't receive any training. That was just to compare against general trends, I guess. So we had different groups and compared the change in pre-post test between the different groups. Again, to make it short, the results did not show no clear evidence of training effect. And again, probably would take a little bit longer to explain potential explanations for that. One potential explanation for it is that those types of tests are not sensible enough for measuring basically what you train in a 3D environment. Because with those tests, what you have to, the skill that's necessary for solving those types of tests is you have to interpret a 2D drawing and make sense of a 2D drawing and sort of mentally transform this ideally into a 3D object. If you can't do this properly, you're not good at those tests. When you work in 3D space, you don't have to do this switch and this mental transformation from a 2D object to a... So one of the potential explanations for a non-clear results was that the tests used here are probably not sensitive enough for measuring the type of spatial knowledge trained in a 3D environment. But anyhow. Some other examples for, as an example for collaboration. As you can appreciate, different types of interfaces support collaboration in a different way. A desktop type of interface, it's not the best interface normally for supporting collaboration because you have one keyboard, one mouse, one sort of focused screen for one person. With an augmented reality interface, you have those tangible user interaction devices to some extent. And so you just have a different type of interface that supports collaboration in a different manner. And so Mark was sort of back in the days quite interested in this question. So this was a study from Mark and his colleagues where they looked into user collaboration. So they had a bunch of objective measurements and subjective measurements and observed people how they interact with those different types of interface, like face-to-face, without any technology, here with an augmented reality setup, and here with a projector-based setup. And so they compared collaboration between those 3 different conditions. They looked at sort of analyzing gestures and word utterances, and they found that in the end, the augmented reality setup was more akin to, comparable to face-to-face rather than projection. So the projection interface was quite different compared to face-to-face and augmented reality interface setup. Another example to give you more sort of an idea about qualitative analyses. So in this study, the researchers were interested in evaluating a mobile augmented reality interface, and so they compared an interface where you could track basically a map with your mobile phone, get in sort of an AR view, to a standard Google Maps type of interface on a phone. And the task was a treasure hunt. So you had to go different locations in a city to solve different tasks. And so they were interested in analyzing user interaction, and they did this with video observation. So researchers followed the participants with video cameras and then analyzed the videos afterwards. Then it was also a good example for triangulation of different methods. So they combined the observations they gathered through the videos with questionnaire data as well. It's always a good idea to, as we said, triangulate different data sources and get sort of a more integrated picture of your question with input from here, for example, qualitative data and quantitative data through questionnaires. And so to give you sort of an idea what different kinds of results you can get out of qualitative compared to quantitative studies is that they found how those interfaces basically support interaction. They found that the AR interface, again, supported collaboration a lot more than the more personal map type of interface on the phone, because it's just the way it's sort of it affords collaboration, and use of gestures and all those kinds of different things were different between the two types of interfaces. Just a quick example for a more sort of usability study. So there, the researchers were interested in sort of the user experience and acceptance of sort of a new AR interface in a medical setting. So they had this, I don't know what the machine actually did, I think blood flow or something. The interface showed the operator how to operate the equipment. So they just give pointers towards, okay, press here and then do this and do that type of thing. And the idea here was not to compare it against another interface, but evaluate the usability of this system and user acceptance in a medical setting. Because as you can appreciate, in a medical setting, if you introduce a new type of interface, you potentially well, it's a quite sort of critical environment, so you don't want to introduce sort of a an interface that's not working or unusable, not accepted by medical professionals. Yeah, so this is basically the type of information they got. Just put the cable in here, connect the cable. So it was more a training operating manual. So they get a feedback, found sort of that it sort of was accepted quite well by the professionals. It was good enough for professionals to complete tasks without additional assistance, and those types of results that you can get out of such a study. And they were also interested in sort of more ergonomics, and this usability type of study was quite helpful in uncovering those issues as well. So what works in terms of ergonomics, what doesn't work that well. And this study, I'm just going quickly through, I guess, the next slide, just shows a good example for the different steps you can go through in a development cycle, I guess. And they talk about the different studies they did in their development cycle for their application. So they started off with user task analysis, just the first step before they started creating the system. So they did actually a task analysis. What is it we want to achieve, or users actually want to achieve? So always a good place to start. Next step was they developed a low-level prototypes and did some expert-based evaluations. They said, like, no, you don't need users at this stage. Potentially, you can do some of your studies with experts in early stages to give you quick input to if you're on the right track or not. In the next step, they did sort of formative user-centered evaluations. These already, as the name says, involve some users. And the last step, I think they didn't report it yet in the paper, sort of a summative comparative user evaluation. That would be where you then have the end product and compare it to a competitive product, for example. So there's different stages you can go through. And this paper gives a good example, I guess, of the different steps the researchers took in the development of their system. So it was just a quick overview, I guess, of some studies. They are in the paper. If you, I can give you sort of access to the, if you're interested, to the paper as well and to the resources. Otherwise, you have the links here as well in the and just give you a quick overview. So we probably can have a quick coffee break and then jump into the next set of slides where we talk about participants and how to work with participants. So talk a little bit about participants, how to recruit them, how to work with them, what to do with them. And sort of, well, the question is, well, how many? That's one of the pressing questions you always get this question, so we might as well talk about it. So, well, before you ask, well, how many you need to know who you want to have for your study. And where you find them. What you find quite often in, well, let's again sort of research papers. So we're talking about sort of, well, a lot of stuff is research based. So we always talk about sort of examples from research, not just pure usability type of studies. But you find them you find them in usability studies and research papers, to be honest. Those things. Researchers, come up with sort of a research question because this is sort of a niche problem, hasn't been studied yet. So they come up with this study design, and which is quite solid and everything. And then as soon as you come to the participant section, you see like, we recruited, let's say 20 people from our university, from our lab to study for our study, and which to some extent can be fine. But the issue then arises in the discussion with that we found that this is a generalizable result. So the question is, and the question you have to ask yourself, so how does your study population, your sample, influence or impact on the results? If you are interested in a specific user group, like a tool for professionals, and you study you study the tool with your colleagues, your students, well, does it work? It can give you proper results, but not necessarily. And you find this quite often that it's sort of those what we talk about later about sort of those convenience samples. You just basically look in the hallway and just grab the first person you see, like, oh, do you want to participate in my study? So you always should sort of think about, so how does this, well, let's put it, potentially influence my results? So the factors that might sort of have an influence are sort of the general suitability of your sample for your study is, well, backgrounds in terms of education, backgrounds in terms of cultural backgrounds, expertise, gender, age. So all those factors have a potential influence on the results. So, if you study a new interaction, well, a new text messaging technique on a mobile phone, and if you study this only with teenagers, are the results then generalizable towards the general public? Elderly folk going to be sort of produce similar results than teenagers, if you know. But you think it's like, well, that's so obvious. So why we're talking about this? Because you will find it in tech reports, research papers all the time that when it comes to recruiting participants for a study, not proper. Well, sometimes, well, often the researchers or the people don't take proper care in choosing a correct sample for their studies. Well, which brings us to the point of representativity, I guess. And every time when you pick people, you are sampling, out of a population. And in the end, every study you run is representative for the population you took your sample from. So if you took your sample from the student population or the lab population here in the HIT lab, now you can be sure that the results are going to be representative for the students or from are representative for people studying, or are interested in studying at the HIT lab. But the question arises on generalizability of your results. So always keep in mind that the sample is sort of a part of a population, and with statistics, in the end, what you want to do, you want to generalize your results towards a population. So if you do your hypotheses and your test, and you get your significant results, what you actually want to do with those results, you want to generalize. Well, you're not interested in the specific sample you've chosen. Well, no, you're not interested in the 10 people. Well, to some extent, but not specifically in the 10 or 20 people you studied your question with. What you want to do, you want to take those results and generalize them, and say like, okay, we found that this, there's sort of good evidence that this generalizes towards a general towards the population you're interested in. If you're interested in the general public, I don't know, for your interfaces and radios, you most of the time would be probably interested in sort of not a specific user base, but most likely, whoever uses radios and or it depends basically on the product. If it's a specific product, I get for
in a professional environment.
Professional environment, yeah. But in this sense, you probably want to make sure that you test it with
the right people.
With the right people,
But I was thinking in the opposite case. For example, in global products, it's really, really important the cultural background in the people, or only you propose, and after with a light training, the people compensate the lack of ability to operate some equipment. It's really I believe that a cultural background is an uncontrolled variable, right? It's not.
Well, and it's certainly a challenge. It's certainly very very challenging. Well, one there's sort of those nice examples out there where just product names can be quite, can have different meanings in different cultures.
Icons are a good example.
Icons, yeah.
I remember working with a company. They had a tree stump as an icon for a log file.
Mm-hmm.
Just it only made sense in English, and I never changed it.
And with icon, just remember we had some years ago a presentation from a Korean researcher, and they did microwaves, I think, and one of the icons was a small, I think it sort of looked like a sun, or just like a small icon with sort of, and I don't know in which cultures this was mistaken as a bodily part where sort of people eject their remains, I guess, and although it wasn't meant like whatever an objectionable thing. It was just a sun, or it's just as a matter of I think power or whatever. But some mistook that as Well, another classic example is Mitsubishi. The Jeep. The Pajero.
Yeah. In Spanish,
yeah. In Spanish, Pajero. It means something.
Doesn't go.
Yeah.
There was a car called Nova.
Mm-hmm.
Doesn't go.
Nova. Nova.
Nova. Yeah. And so you certainly have sort of challenges there, and it's difficult to get it right for everybody. But in the end, I think the message is you just should make your best effort to choose a representative enough sample that it's sort of still manageable for you to recruit it. If you always have to would have to recruit people from different cultures, well, where do you get them? And you just can't test for everything in all different parts of the world in the end. I think the main message is think about it. How does the selection of participants for your study influence the results, and just make your best effort in trying to recruit a representative enough sample. Even then, things can go wrong, But as long as you make your best effort, that's basically what you should, in the end, I guess, focus on.
It may be that you have to change your study to suit the participants, like have remote testing if they're all overseas. These are sort of options you should consider. If it's really important to make sure that it works across different cultures, for example, then you have to design your study appropriately. And sometimes it's if it's feasible, sometimes it's probably not. And then you just have to probably take other measures or test it multiple times or whatever.
Depends on your markets that your company's selling in. If there's some main markets, and for example, they go to South America, and you have to the whole Latin market, you will test it with these people. If it's important to them, they will do it.
Yeah, exactly. Yeah.
Yeah, but sometimes I believe not happens, right? Because the user must adapt to the product or training to be able to test the product, to use the product.
Well, it's still quite common. This such an approach, but I think in the end, really.
Yeah. Well, my question was most in the sense that how you can generalize your results if the background of your group of studies the same cultural background.
What you basically should do, you always exactly report in your report how and from which population you recruited your participants, and this gives the reader a good idea about sort of making the best judgment as well about how you interpret the results. And so it's not it's not always the case that just because you study a certain thing with people from one culture that it doesn't generalize towards other cultures, but there's potentially this problem. So what you basically should do, probably don't be too bold with your generalizations on the one hand, and report it, that everybody can make their own mind up on sort of how you interpret the results and if it's sort of a feasible thing to do or not.
But there's probably studies out there that are maybe country-specific. Let's say, for example, if you have a particular a sample of a particular country and their results, how applicable is it to another country, to a particular other country? So you can make this assumption based on other studies that have been done in a similar field.
That's yeah.
For example, you could say let's say the English user interface may be completely unacceptable in a particular environment, and that, so you don't have to study that again because that has already been established.
If you have good reasons to and good evidence that's the case, well, certainly, that's certainly the case. Yeah. So it really depends. I guess the main message is, on the one hand, be careful, think about how those factors can influence your results, and make it obvious to the reader or to your customer, whoever is sort of the recipient of your results, I guess, who you're catering to, who it was you tested your application or your product or whatever with. There's different ways of sampling or getting your participants. So the one way would be what's called random sampling. The random, in a sense, that every member of the population has the same chance of being selected, which is basically what you should strive for. Sometimes rather difficult, I guess, but it depends on who the population is. No, it's not always that the general public is your population. Sometimes you're interested in experts. If you're interested in experts, your population is a lot smaller, your population of interest, and you still can do a random sampling of that. So if you're let's say, I don't know, you're interested in augmented reality experts in New Zealand,
there are not that many around here. So you have a sort of an quite sort of concise set, or the population are not so big. So we can still do sort of random sampling in this population. So it's not necessarily that you always have to generalize towards the general public. It really depends on your specific question you want to have answered. Another way of sampling is called what's representative sampling. So again, well, who's the populations of these specific users? Yeah. Well, what we talked about, convenient sampling, that's what the name says. It's just the most convenient way of just basically grabbing whoever you can get hold of. And that's what you find quite a lot in research papers, unfortunately. And it's not just in HCI, it's in all kinds, in different disciplines. Psychology is a classic example that a lot of psychology-related studies are run with psychology students. There's even, students get course credits for being participants in studies. It's just, in the end, things to be aware of. So, let's talk about sample sizes, the question that always comes up. Why does the question come up? Because everybody wants to hear, you don't need that many. Because that's the easy way out, I guess. I'm sort of always like to shy away from giving specific numbers, but just for the sake of it and just to get over some of the things, there are those rule of thumbs out there, that you should have at least 15 or 20, some say like you should have at least 8. I'm still sort of a little bit uncomfortable to come up with sort of those rule of thumbs, or because they are not more, what they are, the rule of thumbs. Although it's just as a general guideline, they might be sort of to some extent valuable. So just try to have at least, let's say, 15 to 20 participants per condition. So what does that mean? So we're talking about different study designs. You can have within subjects design, you can have between subjects design. So if you compare two interfaces, you compare your Kinect to your Wii. So which one is more enjoyable? Which creates a more enjoyable gaming experience? So you can study two groups. One group does the Kinect, one plays with the Wii, and then you compare sort of enjoyment scores or whatever, how you measure it. Or you can set up the study as a within subjects design. You can have one group doing both conditions and then just compare how enjoyment levels differ between the two conditions. So in case of a between subjects design, that would mean have 15 to 20 in each of your conditions. So you have a total of 30 to 40 people in your study. If you do within subjects design, you would have at least 15 or 20 overall. And that's why in HCI, quite often, one of the reasons why as within subjects design is chosen, because you just don't need that many people to study your question, with the pros and cons that come with it. Sometimes it just makes more sense to do it within subject design as well. Then you killed two birds with one stone. But sometimes it just makes more sense to study a question with within or between subject design, or if you're, for example, interested in a question where you compare different gender differences, you automatically have a between subject design because you're comparing males and females. But then my recommendation would be to have at least 15 or 20 in per condition. Okay, that's sort of one side of the medal. It's what we're talking about here is if you want to apply statistics to your for analyzing the data. If you're not interested in statistics to analyze your data, not in quantitative analysis of your data, you don't need that many people. And some of you probably have read Nielsen and Nielsen's recommendations. They know that you need 5 not more than 5 people for your usability study. That's fair enough. But Nielsen is not talking about those types of research studies. Nielsen is talking about usability studies, where you're not interested in applying statistics or inferential statistics. Because what you do there, and we talk about this then with the usability testing, it's just a different, completely different approach to studying a question. With a usability study, you're interested in uncovering usability problems, usability issues, problems users have with interacting with your interface. And there you don't want to compare with statistics different groups, but you want to have a user use your product, use your web page or whatever it is, and then observe them and see where are the difficulties. And then do your iterative designs to solve those issues and so on and so forth. So those types of studies can be done with a lot less people because you don't need 20. You don't need 15 to 20 people to uncover the major usability issues with your product. And the argument even goes further. If you do usability testing, it's better to do multiple small tests. So you do your first test, you find the major problems with 5 people. Then you make some changes to your product, your prototype, and then you have a new prototype, and you do another set of studies, with 5 people, and see if there's problems are solved or if there are other problems coming up, and so on and so forth.
Would you recommend to reuse the same people or different people?
Depends on, well, really depends, I guess, on what you want to find out. Same people probably could give you insights towards if the issues have been resolved, I guess. Using new people could give you other types of insights, like are there other problems that
just increasing the sample, really, isn't it?
I think it just gives you a different picture on just different types of results to some extent. It's sort of a different sample, yes, but normally your prototype has changed as well. So I probably would see it as a sort of a mixture between a bigger sample, but you're doing sort of a new type of study then as well with sort of a new prototype. So I guess it really depends on what you want to get out of your study. It could go both ways just somehow. I guess with using the same people, you get, well, you can see if the changes have been resolved, but you probably won't find that many other types of issues or problems. With a new set of participants, you probably find other types of problems other people have with their prototype. So I don't know. It really depends on what you want to find out, I guess.
To do both and just see how it goes.
Ideally, you do as many tests as possible, but then you probably have to weigh up the pros and cons. And
as a learning experience, it might be a good idea. To do both.
Yeah, definitely.
And then just see how you go, and then maybe rely on those results for future.
Yeah. Okay, so is it clear what we're talking about, the difference between usability type of studies and those research studies where you want to compare interfaces and do statistics? So we're talking about those when we talk about the 15 to 20 people. Sometimes you find you should have at least 8 per condition, and I find this quite, well, that's just a little bit too low for getting sensible results for, if you want to apply statistics. So now with 8 people per condition, it's just the problems you potentially run into are.
There are some relationship with the number of independent variables that you can measure. For example, I was thinking in your case, in professional users, that you want to know, for example, know what is the cognitive charge to learn to use the system, and you want to know deeply what is the way that they are learning. You need measure a lot of dependent variables. And maybe every completion of task take, I don't know, 1 hour, or because it's very, very specialized, the system. You can do the study in just a few people because the study take you a lot of time per
Again, it really depends what you want to find out. If you want to have more in-depth appreciation of how people interact with the system, you probably don't need to compare it against another study with statistics, you probably do a qualitative analysis of how people interact with it. It really depends what you want to find out, I guess. The number of independent variables certainly has an impact on, if you want to do a quantitative analysis, the amount of independent variables certainly has an impact. Again, depends if you study the independent variables as between subjects or within subjects. If you have a whole lot of different conditions with independent variables and you study them as between subjects, your overall sample is going to be quite huge. So here. But there's certain things that that have an influence on sort of those considerations, how big the sample should be. So the question is, how big is the difference, the effect size you're interested in? So just an example, If you expect very large, a huge effect size, large differences, you don't need that many people to find large effect sizes. So if you're interested in for example, the speed difference between a jumbo jet and a propeller plane, you don't need a huge sample to make to find a speed difference between those two different types of planes. But if you're interested in the difference between jumbo jet A and jumbo jet B, who sort of use similar technologies, and which one is more efficient, which one is faster, you probably need a bigger sample to, or here the example would be between the speed difference between turtles and rabbits. You don't need a huge amount of turtles and rabbits to see if there is a speed difference between turtles and rabbits. But if you want to find if there's a difference between different populations of rabbits, brought up in Christchurch or in Timaru, I don't know. And you probably think like, well, it's a little bit further north, they get more sun in Christchurch, so it might be faster. I don't know, whatever your question is. You probably need a bigger sample of rabbits to see if there's a difference between those two rabbit populations. So it really depends on the effect size you're interested in and want to study. The good news is you can actually calculate your optimal ideal number of participants. The good news and bad news, to some extent. Good news, you can do it. Bad news is you will be surprised by the results because they normally don't work in your favor if you want to have small samples. Because in the end, it's most of the time just showing you that you need more than you anticipated. So again, what you need to calculate to do this power analysis, you need your alpha level, which you set anyway, which we talked about, your 5% alpha level, which is sort of your probability of rejecting, of incorrectly rejecting the null hypothesis, blah, blah, blah. The beta, or to be more precise, the 1 minus beta, that's the power. And that's the probability of observing a difference when it really exists. And you need this effect size. So that's the effect size you're assuming that there is. And that's the most tricky bit, because you have to come up with a good reason for this effect size. Ideally, there is prior research that looked into typical effect sizes for your research. If there's already studies out there, it's like, okay, well, for a speed difference between our two rabbit populations, we assume that there is a speed difference of at least 10% or whatever between the two populations. Then you can use this as your effect size for your power analysis. So then you can look, okay, given I have my alpha set at 5%, my beta, or my power is normally set at 80%. No, don't, yeah. We have to go into too much detail for that. But those are normally given and set at sort of 5% and 80%. But the effect size, that's what you probably, what you have to come up with or design. Either make your best informed decision about this from your research, or ideally based on prior research. And then you can plug this into this power analysis tool, and then it tells you the ideal sample size. What does that mean? The ideal sample size is if you test that many people, you can sort of be sure to some extent that it's, if you don't find a significant result, that it's not due to not having enough participants in your study. If you test more than that, you shouldn't do this either, because then, if a huge sample is what we said, your differences, even if they're not meaningful, work at some stage get significant. So with a huge samples, even minute difference is going to be statistically significant, although it doesn't say that they are meaningful differences. So ideally, you calculate your ideal number of participants with those tools, but you don't find it that often in HCI. You find it you find it quite often in medical research. If, for example, apply for a health research council grant, in your grant proposal, you always have to put in power analysis to show that you did your homework before, and to give sort of a good reason why you want to test that many people. And arguments probably could go like, well, that's more critical research. If you test a new drug, you want to make sure that you have a sort of a very a solid case for your user study design, because you don't want to put out drugs that are not properly tested. And some probably argue, well, with HCI we're not dealing with that critical information. But still, I don't know if I totally agree with this argument or not. But just, I guess, to make it short, it's not that often used. I basically have hardly seen it in sort of in HCI papers that power analyses are reported. Okay, we talked about those. But this question, fewer participants are needed for qualitative studies. So if you're doing interviews, if you're doing user observations, you don't need that many people. And it's not feasible. You just can't, because the data, gathering the data and analyzing the data just takes a lot more time as well. And if you do video analysis of 20 people, it takes a long time. If you have estimates are, if you have 1 hour of video and you want to do proper video analysis with 1 hour of video, you need at least 5 to 10 hours for 1 hour of video to do proper analysis. If you have 20 hours of video, you do the maths.
You also get more nuanced data per participant.
Yeah.
In these kind of studies.
And in the end, and you're again interested in a different, probably in a different question. You're not interested in doing statistics. You're more interested in going into more depth and covering different things. So you don't need that many people because for those types of studies and analyses. And well, usability studies. There's this suggestion. I don't know, again, there's a lot of discussion about the 5 users or how many, but just to give you a ballpark figure, that's you just don't need a huge sample size for those types of usability studies.
Sorry, I don't understand very well what is anthropological studies and ethnographic studies.
Well, ethnography is basically comes from a different discipline, but HCI, for example, and other disciplines sort of borrowed some techniques from there. So the idea is that you immerse yourself in the environment and observe the researcher. Yeah. So you immerse yourself in the environment and study. There's a whole chapter. We don't have time to talk about this in the lecture. So if you're interested, by all means, just read the chapter, which gives you a nice overview of ethnography studies. The idea is that you immerse yourself in the environment and do your research as sort of participating, but from within the environment in a more observing role, rather than sort of compared to
if he will a participant more, or
not as a participant, but you're immersed in the environment. So it's a little bit sort of difficult to explain sort of in a few words. So by all means, it's probably just 10 or 20 pages.
And anthropological is another approach.
Well, ethnography is a method within anthropology. Anthropology is sort of a field, I guess, and ethnography is a method which traditionally was used in anthropology, and HCI basically grabbed some of the ideas and just adapted it for HCI research, the ethnography research approach.
Yeah, but as a researcher, you can both be, there are different levels of immersion. You can both be an observer, and you can also be a participant, where you sort of immerse yourself more into the environment of the people that you
In the
study.
ethnography.
Yes.
Okay.
It's a completely different approach to what we talk about sort of
In this course.
in this course. It's just that the focus, I guess, of the course. We can't talk about everything in detail, and I guess, probably depending on my research approach, and the general lab approach is more on the quantitative side of approaching or studying things quantitatively, and that's what we focus more on here in this course, I guess. Just some other general factors that influence your selection of participants and how many participants you can include in your study. Time, for example, it's a huge factor. If it takes very long, you just talked about this. If it takes 5 hours per participant to study something, I don't know. You can't have hundreds of people because that's just it's just not practical. Sometimes it's difficult to find certain ideal sort of participants. I just think back we did an industry a study with our industry partner here in Christchurch, and the main problem for the whole project was that we couldn't get experts for their interface. So we developed a new interface. Everything was good and fine, but it was just too difficult because I think there were only around 4 or 5 experts within New Zealand, and because the main market was overseas. So it was really difficult to find those suitable participants. And it's a real world problem. Pilot studies, we talked about pilot studies. So that's just before you start doing your proper study, you do a pilot study. You don't need 20 people for a pilot study. By no means, pilot studies are just test runs for your designs and for your study. And you do those with 2, 3, or how many you think it's sort of useful. But sort of sample size of a pilot studies are a lot smaller than normal sample sizes for regular studies. How do you recruit participants? Different ways of recruiting participants, I guess. You can have flyers plastered all over the place, town, university, with those strips. You can have just send out emails, ask people word of mouth. And so there's different ways of recruiting participants, and really depends on, I guess, your intended population as well, which is the best and most suitable way of recruiting participants. There's sort of those type of databases. We always try to do this in the lab, but it's just too much work somehow to maintain those databases. It's always it sounds quite, the most straightforward approach, but it's not that easy actually to create such a database and to maintain it, especially. So just some ethical issues, and probably, in with that as well. There's every time when you run a study within sort of at least here in New Zealand and most other universities, there is a ethics committee, a human ethics committee that you have to consult before you run your study. And they just check that your study design, your plan, your questionnaires, what you do in your study complies with ethical standards. So what you normally do, you start off with an information sheet for participants. So that's what it's, who's the researcher, who's the research, what's the research institution, what's the study going to be about. And so informing the participant about the study content, and their rights, how the data is going to be used, and those types of things. So all this is part of the information sheet, and then as a second part of this, there is a consent form. So your participants then should have a way of either giving their consent to this or not. If they don't give the consent, you shouldn't use them as your participants. So your information sheet, and then they have a separate thing where it's like, okay, I have read the information, I agree, and consent to my data being used as to participate in the study, and my data being used for research purposes. If you take pictures, you should take separate consent for that as well. It's like, okay, I'm okay with my pictures being taken and used in a specific for a specific use, like research papers or web pages, for example.
Confidentiality goes both ways, though. What about them kind of having a non-disclosure argument as well? That they will not talk about what they have seen because it may be.
Yeah. Well, so confidentiality and non-disclosure is sort of always. I guess again depends on what's the part of your. Well, I guess in a commercial setting, non-disclosure is probably a little more. That can be critical in the university environment as well. I don't know. That's sort of, I guess, to be decided on a case book. If it's important, you certainly should include that as well. Well, in the end, most of the studies we do here are going to be then used as a research output then anyway, and then it's out in the public domain. So non-disclosure is sort of not a big part of
applications.
Well, I guess depends on in which stage you are in your development, but that's
probably also building up a relationship with your participants.
Yeah.
If you want to reuse some of the same participants over time, you probably have to build up a relationship.
Yeah.
Of trust.
Well, certainly, definitely, yeah. And that's why you always, not just if you want to reuse them, but anyhow, you always should treat them with respect in any way to build up sort of trust and a good relationship. Because I guess if they don't feel welcome and comfortable, the results are potentially not going to be of high quality potentially either. Yeah. So you always should consider potential risks, inform participants of potential risks. Most of the time, sort of HCI experiments, the experiments we're dealing with are most of the time low risks. There's potential fatigue or eye strain or those type of things, but we're not dealing with that often with potential health risks. So that's, but just think about potential risks, and if there are risks, you have to inform your participants of those and tell them the rights that they can stop participating in your study at every time, and so on and so forth. Privacy, very important. What you do with the data, you always should make sure that data is anonymized, that it's is kept in a safe place. If you have, for example, questionnaire data, well, ideally the questionnaire shouldn't identify the person per se. If you have to match data source or questionnaires, you should, for example, can use IDs, but you should not put names or stuff that identifies participants directly on the piece of your data.
Sorry, I was thinking in the research that involves children participation, you need the consent of
parents. Parents normally,
and the teachers could be.
Yeah. So we did some years ago. We did a study in schools. So we had to first ask the principals, teachers, the board. What was the board of trustees? Yeah. No, to basically first inquire if we can do it in the first place. We had to go through human ethics committee here in university, and then get consent from the the parents. So it can be quite an involved process, I guess. Yeah, but especially if you're dealing with children, you want to make sure that everything sort of follows a protocol, because if things go wrong, you don't want to be in an uncomfortable situation, I guess. Yeah. So you should just make sure that privacy is maintained. So that inform people how you protect their privacy in this informed consent sheet. So we talked about those issues, sort of, inform about the reasons of study, procedures, potential risks.
I have a question to this.
Hmm?
Sometimes you might want in a study to actually not tell participants the true purpose.
Yep, that's somewhere, I guess, way back then? No? Deception, potential.
The ethics committees.
Yeah, so sometimes it's necessary to involve some deception in your study. If you you should basically, in this case, make it clear, in your ethics proposal as well, and then the ethics committee will check for that as well. The guideline there is that it shouldn't be unnecessary deception. If it's really necessary and it's not going to harm your participants, it can be sort of a feasible way of studying your question. What should happen certainly is after your study, there should be a debriefing session where you explain to the participant what happened, and then they still can decide, well, I don't want you to use my data or not. So that's just how those things normally happen. So I guess the guideline there is it should be no unnecessary deception in there. If it's necessary to answer your research question and there's no harm going to happen to participants, then it's a feasible approach. It's always going to be scrutinized and checked by other people first, who probably will give you guidance on that as well. But then it's sort of necessary after you complete your study and finish your study to have a debriefing session where you inform your participants of what happened. Then they still can decide if that's. And there's examples. We are probably a little bit over time today, so we can talk about this next time. There's classical experiments, especially in psychology, where this has been used as the Milgram experiment. I don't know if you probably heard of that, where deception was an integral part of the study. And since then, it has become a quite important topic, because before that, this was one of the reasons as well why ethics committees, one of the reasons, I guess, why ethics committees came into existence, to control basically the researchers as well, that they can't just do whatever they want, I guess. Cool. Because we're a little bit over time, we probably should stop here. Just thinking about last time we had an assignment about designing an informed consent form. So I might. Well, let's sort of skip it as an assignment, I guess. Have a look at, just for your personal, I guess, as for your personal interest, I guess, and personal development, let's put it that way. Let's not make an assignment out of it, but I'd sort of suggest for you to have a look at the Human Ethics Committee website in Canterbury. And there's sample ethics informed consent forms. So the idea would be, to design a draft informed consent form for a hypothetical study you want to do. And then if you want to do it, I'm more than happy to have a look through it and give you feedback. Just informal feedback, I guess. If you want to do it, and then you can do it that way. Cool. So we just. Oh yeah. By the way, organizational thing to clarify. Next week I'm not going to be here. I'm going to be overseas. And so I talked to Mark. So Mark is going to do 2 lectures next week. So he's going to do Tuesday and Thursday next week. And he's not going to be there the week after, so I'm swapping with him. So I'm not, and the week after next week, we're going to have 2 evaluation lectures, Tuesday and Thursday. And talking about the rest of the slides we didn't have a chance to talk about today. It's some more 7 or 8 slides, and then talk a little bit more about analyzing user data. So a little bit introduction to statistics. Thank you.
Thank you very much.
Thank you, Andrew. That was great.